Hello everyone, I am Akash, founder and director of Prime Minister of Mathematics, Amravati. In today's video, we are going to solve a question on linear algebra from Maharashtra State 2024 exam. The exam was conducted today on 7th April 2024. The question is, the dimension of the vector space over R of all 5 cross 5 upper triangular matrices with complex entries is, these are the options. So let's begin the solution. We will solve this question via two methods. First by using formula and then second by using theoretical method. Okay. So let's begin with the formula method first. Okay. Let us first write what is V here. The V, that is the vector space, given vector space is the space of matrices. Okay. And the matrices, all matrices in this space are of size 5 cross 5. Okay. And the entries, that is Aij, belongs to complex number for every I comma j. Okay. And all the matrices are upper triangular matrices, that is matrices whose entry below the main diagonal are 0, that is Aij equals to 0 for every I greater than j. Okay. This is the condition for matrix to be upper triangular. Okay. And this is condition is due to the given condition, because given that the entries belongs to complex number. So this is V, and we have to find the dimension of V over R. Okay. So we will first solve this question with the help of formula. We know that dimension of vector space of all n cross n upper triangular matrices with real entries, okay, is equals to n into n plus 1 by 2. Okay. Note that this formula is for the matrices with upper triangular matrices with real entries. So this formula does not work here. So those who have solved this question with the help of this formula, they have definitely done this question wrong, because they have marked the answer 5 times 5 plus 1 by 2, which is 15. They have marked this answer is 15. Actually answer is not 15. Okay. Answer is not 15. This option is wrong, because this formula does not work here, because the entries are complex entries. This formula works for the dimension of vector space of all n cross n upper triangular matrices with real entries, not with complex entries. So we have to modify this formula for the matrices with complex entries. Okay. And as each entry Aij can be written as Aij is equals to the real part of Aij plus I times imaginary part of Aij. Okay. So if we form the basis of the vector space here in this case, then that basis only cover this real part, okay, not this imaginary part. That's why we have to modify this formula, and the formula that work in this case will be 2 times this formula. That is, so this implies the dimension of the vector space of all n cross n upper triangular matrices with complex entries. Okay. Dimension of vector space of all n cross n upper triangular matrices with complex entries is 2 times this formula, that is equals to 2 times n into n plus 1 by 2. So these two get cancelled. So the formula reduced to n into n plus 1. Okay. So by using this formula, the dimension of the given vector space V will be, dimension of V is equals to, here n is 5 because size of the matrices are 5. So the dimension will be 5 into 5 plus 1, that is 30. So the answer is option A. So that's why I always say to my student that please do not memorize the formulas, okay, only. Do not memorize the formulas only. Always try to see the concept behind those formulas. As we can see here, this formula only work for the matrices with real entries, but do not work for the matrices with complex entries. So those who solve this question using this formula will be definitely done this question wrong. Okay. So this formula do not work here. Okay. The formula that will work here is this. And we just obtain this formula, this new formula. With the help of this formula, we just modified this formula to work for the matrices with complex entries. So we have to solve this question with the help of formula. Now we solve this question with the help of theory. Okay, those who are just interested in the method using formula, they can skip the next part of the video. However, I must say, please do not skip the next part, because you must know what is the theory behind the formula. Okay, so let's start the question by using theory. Let's solve this question by using theory. If A is any general matrix that belongs to V here, then A can be written as A11, A12, A13, A14, A15, A21, A22, A23, A24, A25, A31. Sorry, because the matrices are upper triangular matrices. Okay, so this entry will be 0, this entry will be 0, this entry will be 0, and this entry will be A33, A34, A35, 0, 0, 0, A44, A45, and last row will be 0, 0, 0, 0, A55. Okay. So any general matrix that belongs to V is of this form. It is 5 cross 5 matrix, and okay, so and it is upper triangular, that is all entries below the main diagonal are 0, that is it satisfies this condition. And all these entries, that is Aij, belongs to complex number. So all Aij's can be written as Aij is equals to the real part of Aij plus I times imaginary part of Aij. Okay. We have to find the dimension of this vector space over real number. What is dimension in general? Dimension is the number of vector present in the basis of that vector space. So we have to first find the basis of this vector space over R. Okay. And we know that any vector belongs to the vector space can be uniquely written as linear combination of basis vectors. Now, I first write A as a linear combination of some vectors. Now, I can write this A as, note that here Aij A11 is nothing but equals to real part of A11 plus I times imaginary part of A11. Okay, because A11 is complex, belongs to complex numbers. Okay, so I can write this as real part of A11 times 1 0 0 0 0 0 0 0 0 0, and all the rest of the entries are 0, and this matrix is 5 cross 5. Okay, plus real part of A12. Now the first entry will be 0 and the second entry uh, will be 1. Okay, 0 0 0 and the rest of the entries are all 0. And the size is again 5 cross 5 and so on. Okay, up to so on. Now if when we come here, the real part of this entry, actually this entry is 0, so 0 plus 0 I, so the real part of this entry will be 0, so overall term will become 0, so we do not need to consider this term. Similarly, we do not need to consider the matrices for these all 0 terms, so we just consider the matrices for the these general terms. Okay, so the here we up to so on, this will go up to this a55. So here will be real part of a55 times the matrix 0 0 0 0 0 0 0 0 0, all the entries 0 except the last entry. Okay, the size is again 5 cross 5 here. Okay, so up to now this the matrices with just entry 1 and rest of the entries are 0 will cover just real part of the matrix. These matrices will just cover the real part of the matrix. Now we have to cover the imaginary part of each entry, that is we have to cover the imaginary part of the matrix. Okay, and for those, now first entry, the imaginary part of the first entry, that is I times imaginary part of, sorry, I times not, the imaginary part of a11 times the matrix I 0 0 0 0 0 0 0 0 0 and the rest of the entries are 0. Okay, this is 5 cross 5 plus imaginary part of now second entry a12. Now the matrix will be here, first entry will be 0 and the second entry will be I 0 0 0 0 0 0 and all the rest of the entries are 0. Okay, and so on up to this imaginary part of a55 times the matrix 0 0 0 0 0, all the entries are 0 except the last entry, and the last entry of the matrix is I. Okay, so now we can see that this the new matrices, that is imaginary part of a11, imaginary part of a12 and imagine up to so on imaginary part of a55 will cover the imaginary part of this matrix. Okay, so we can see that each of these matrices will cover all the parts of this matrix, real part as well as imaginary part. Okay, we can see that A can be expressed as linear combination of these matrices E1, E2 and so on this. Okay, so we can see that A can be expressed as linear combination of these matrices, and we can check that these matrices form the linearly independent set over R. Okay, these matrices form the linearly independent set over R and they span this vector space V. So they form the basis for V. Okay, so they form basis for V, and so we have find out the basis for the given space V, and the basis is this all matrices. Okay, the basis is a set of all these matrices, and so we need to just count. Okay, so we can see that number of vectors in the basis are each entry will require two matrices. Okay, that is one for the real part and 1 for the imaginary part. You can see each entry required two matrices, one for real part and one for imaginary part. And how many entries are there? 5 plus 4. How many non-zero entries are there? How many non-zero entries are there? 5 plus 4 plus 3 plus 2 plus 1. That is, there are 15 non-zero entries. And each entry required two matrices, one for real part and one for imaginary part. So 15 times 2, that is 30. So there are 30 vectors in the basis. So the dimension will be 30. Thus, we have solved this question with the help of formula as well as with the help of theory. Okay. So thank you for watching. If you found this video interesting and helpful, then please like and subscribe to our channel.